Hi, this is Rick Butts, creator of Edestol. This is the first in the series of Quickstart videos I prepared for you, get you up and running as quickly as possible. In this video, we will cover the power model, we will look at the user data file, and we will look at cables. It's going to run about an hour. I wish I could do it quicker, but there is a lot to it. So let's get started. Okay, here we go. Let's launch the program. And let's create a project. Now, if you haven't already, I urge you to look at the video that I posted that shows you about kind of all these different options, backing up, settings, creating files, file management type stuff that goes on with the project. So we're just going to blow by that, create a new project. We'll just call it facility expansion. All right, and this is what you get. Here says we're going to primarily be concerned with the power model. We're going to look quite a bit at cables today, and we're going to look at user data to some extent. I will do more detailed videos for each of these areas down the road, but I wanted to get you up and running quickly. So the first thing is that every project comes with a single source, and you can change the voltage. This is really where your power model begins, and it is, so we're going to double click on it, and we're just going to call it 480 volt. All right, and in this case, this is a utility supply. We're going to make it service entrance. These are the kind of options you get for a source. Now, I'm going to stick with 480 volts, but I urge you, everything pretty much pertains. We also do medium voltage, so go ahead and try some of these. You can put transformers in with medium voltage primaries. You can do medium voltage motors. The only two devices that you can connect to, or the only two switchgear style devices that you can connect into a medium voltage system is an MCC or a switchgear. Let's just do with 480 just to kind of get us started. So we're going to get a 3-4 system from the utility. You can also create so this is a new service. We'll call this the new service. But the way you drag devices into your power model is everything that goes in power is under power. So let's create another source, and we're going to call this say 240 volts, and this is existing. Actually, let's give it a LP1. This is an existing 240/120 volt panel. And this is not a service entrance because this is just an existing panel. And let's go down here to 240, and we're going to give it a 1.3. Okay, so we've got 240 phase to phase and a neutral. So now we have two sources in our power model. One is, let's click on this. We'll call this 480 volt new. Actually, you got to put an underline in there for your tags. You'll learn that real quick. There. Okay, and this is LP1. Click on existing. You could double click on them. In the tree view here, that's what this is called. This is a tree view. We are under the power power branch. When you get to devices, you basically, if you're not sure exactly what to do, you can do a right click on there and you'll get some options. So you could delete this source. You could do different things. When we get a bigger tree view system going, you'll be able to see what those are. But a lot of times you'll just see me this list is popping up. That's a right click there. Okay, so this is a service. So let me show you how this responds. So basically, let's just go with a motor control center, and we're going to drag it to our new service. So what we've got here is, we'll call this MCC2 because it's a new one. This is a new expansion, MCC, 40 volt MCC. And what you'll do is, since this is coming in from a new service, you have to have a main device. We have kind of what are called parallel devices. Those are the devices in general. What you have on this tree view is you drag devices down, and then if you're allowed, you drag another device to that, then you drag another device to that, then you drag another device to that. It will tell you, it will give you error messages, and it'll tell you you can't insert that device at that component if that's not possible. For example, you cannot insert a motor on an existing motor, and it will tell you you're not allowed to do that. So basically it's just one to one to one to one, but we have parallel pieces of equipment. Those are motor control centers, switch gear, switchboards, and distribution panels that allow you to do what are called parallel connections. So a parallel connection or MCC device installed in this location coming off of a new service requires that you have a main device. So we're just going to pick circuit breaker in this situation, and we don't really know what we need. In these cases where you're not sure how big, go to your trip sensor or your breaker trip sensor, and let's just make it 800 amps. We're not sure how much it is, and it will automatically adjust your bus size. You can go bigger on the bus size, but the key factor for breakers and main devices is to either pick a trip sensor for circuit breakers, or if this was a fused. Okay, so basically fused disconnect switches are for 1200 and under. So in that case, let's pick 1000. So basically we got 1000 amps, would be a fuse clip 1200. There's your switch size, and you would go to a 1200 amp bus. If you wanted something larger than 1200, I think this is a bolted pressure switch. They are 800 to 6000. So you could select like a 4000 amp, select your fuse size, time delay, things like that. And then basically your bus sizes, your fuse voltages, your switch sizes are adjusted based on that. You could go larger if you chose to. So just play around with that. You get kind of this supply feeder over here. We'll go through a couple of the features of these devices, and this is standard wherever you see it. You're going to get connected amps, which is just a sum of the downstream connected loads. You get circuit minimum size, which is the value, it's the calculated value by code of all your different loads. So you would take, the equation, it's your motor, full load amps plus 25% of the largest motor, plus the input drive rating plus 25% or 125% of your continuous loads plus non-continuous loads. You put in, and there's some adjustments for input ratings of drives and all that other stuff. So that would give you your circuit minimum size calculated for the loads that you have connected downstream of this device. But in this case, every device also has a circuit design size or a circuit final size, which is the size of the conductors, the cables that you want run to this device. And what we will do is, as we build the system, we compare circuit minimum size to circuit design size. If your circuit minimum size exceeds your design size, you'll get this big warning light up here, and the device will be highlighted, and you will have to make adjustments to the system so that your circuit final size is large enough to accommodate your circuit minimum size. So that's how we do that, and you'll see that across the board with all the different devices. If the motor is too large for the starter, you'll get a warning on that. So you basically just build your system. You don't have to really know all the numbers going in. You just pick a number and it will tell you if, oh, this isn't big enough. Now, the thing that it won't do is it won't tell you if it's too big. So if you take loads out of a motor control center, and it becomes significantly, the circuit minimum size becomes significantly less than your design or final size down here, it won't tell you that, because that's not a warning condition. It just says, oh, you just wanted to leave a bunch of capacity in there for future use or something. So you'll have to keep track of that on your own. So that's your supply feeder. You also got an attributes button over here, and these are where you can add non-size related information for the device. So let's say you want to go ahead and say, okay, this is going to be a bottom left incoming line. We want to go with a tin-plated copper bus. We want it to be NEMA 3R non-walk-in, so it's going to be outdoors. You can add all sorts of, whatever your surge protection device. These are things that can be added, can be deleted, can be changed for each device type. MCC is a device type. So you basically, these are the attributes that you have stored for this. You could add a manufacturer and a part number for this particular device if you want. There's also, since you are coming from a service entrance, you are actually in a tap condition. And whenever you're in a tap condition, you get a tap button so that you can define exactly the kind of tap. We also do have a tap device, but we're not really going to cover that. That's fairly extensive for all the different types that we handle, and I'll cover that in another video. So those are the buttons you could possibly see over here. You also have this little checkbox where you can create a cable. Basically when you press save, you've created this device. If you don't check this, then you will also create a cable, and it will be sized for your final circuit size over here, and you will get to select the attributes of a cable. The way we do cables is every device, should you elect to do that, will have a cable attached to it. And that's, if you're building a string of devices, the cables are attached to the downstream device. Each cable has a from, but the cable tag is actually defined off of the ID tag. So let's go ahead and create a cable here. So for this size, you remember our final circuit size was 4,000 amps. So what we do here, this is your typical auto power cable form. We can create cables a lot of different ways. You can create cables manually. You can create a bunch of different types, voltages. You can also create control cables. You can create signal cables. You can create communication cables. These are power cables, and we divide our cable segments or cable categories by voltage level. So this is a 480 volt cable. So what you'll do is you'll get a form. It's from the 480 volt new source. It is to MCC2. We have assigned a cable tag. It's called P cable, which is basically a 600 volt cable going to MCC2. We give it an index number. These are unique numbers. You can add a length now or anytime in the future. If you have another tag you'd like to use as well, say you got a design coming from another, maybe from Europe or something, for European equipment, and they have cable tags that you want to use as well, you can fill that in here. You have the ability, this cable requirements up here is basically the code level definition for this cable. So what you can do is you're going to get either a single or a multi option. You can do insulated, you can do bare, you can do covered. You can do 90C. These are the different voltage ratings, or insulation, conductor temperature rating, actually insulation temperature ratings that are available in the code. You can use your different materials. There's copper or aluminum, and your insulation. There's your different insulation. Now, when you start getting down to this point, you're now listing insulation voltage levels that are available in UserData. So we're going to go with 600. You can do stranded or solid. Here's your different options. You recall all that you can do: messenger wire, free air, underground. When you do, this is for P cables. If you do medium voltage or higher voltage, you get all their different options for raceways and underground ducts or direct burial or things like that. You get all the different options that the code gives you. You also have the option to, if you have created a cable tray, you can select that cable tray here. And when you select that cable tray, it will then calculate the ampacity based on whatever cable tray installation requirements you have. So that basically is your cable requirement. So the whole idea is select the code category of the cables you want to install. Then you have cable selection down here, which basically lists those cable lists that actually exist in UserData. This information up here is primarily in SysData, which is code data that we are able to access by permission. Down here, we have actually taken manufacturer's information and put it into UserData. So we can pick up, you can do we're doing single conductor, so the only options you have are 1C. You can do multi-conductor, and what that would do is now you have options which are, we can do 3 or a 4C conductor, depending on what you wanted. You can select cable types. This is a manufacturer of a cable type that we've put in, and it will basically match up the sizes that the manufacturer has available to the list in the code and get you ampacity values for selecting of size. So in this case, we're basically doing a 4,000 amp feeder to that MCC. So we're primarily going to do single conductor. I did put in the Chapter 9 Table 5 list. If you wanted to see if, for example, you thought this size over here was not the correct size, it could have been that the manufacturer's list of cables that you selected did not offer that size. So basically, and if you go back to Chapter 9 Table 5 for single conductor, that's all they offer. You don't have a Chapter 9 multi-conductor sizing because the code doesn't offer it. But for single conductor, you can go back and you can get a complete size list. I believe it goes all the way up for these voltages, all the way up to 2000 kc mil. So that basically selects your cables down here. If you want, this is set up so that it matches the ground specs. If we had a neutral conductor required, you could select neutral specs. So let's say, okay, we don't want to use insulated for our neutral. We want to put a bare. You can either do the generic or HWC, Houston Wire and Cable has a bare stranded. So we'll select them as our ground conductor specs. Here is your specs for your phase conductors. If you want to look at the attributes for the cables, you can look here. This cable does not, when we put the cable into UserData, we didn't put any attributes in with it. So we'll look at that a little bit later. So basically now you've selected your cable type that you want to use. You've selected the installation requirements to decide on ampacity, the selected ampacity table. You can go down here, your corrections and adjustments. If you're saying, okay, this is underground, so it's default to, actually, no, we're in raceway, so let's go to underground duct. And in that case, for 600 volt cables, it's still 86. If you go to medium voltage and you go underground duct, this reverts over to 68. So let's just do, say, a 68. Get a little bit of an improvement here. And basically, and we'll just stick with 86. So basically your correction and this is your adjustment, or correction is based on ambient temperature. Your adjustment is based on conductors per raceway. We're going to just do 3 conductors and a ground per raceway, so we're good there. So basically what we are doing up here is we are taking that circuit and we are saying, based on the cables that you sized and the correction values and the number of parallel runs, it will select the minimum number that you require for the phase size that's available. Now remember, over in settings, we said the largest we want to deal with, I believe, is 650. So that's why we got the 600 here. If you wanted to run 1,000s, you could go over and set your minimum to 1,000. And if the manufacturer provided it, then that 1,000 kc mil would show up here. So basically you get all your different, you can also, you want to go, say you want to go a little more than 11. excuse me, a little more than 10, you could do that, and it would, excuse me, it would adjust your phase sizes appropriately. So you can look at all this. Here's your actual, oh, this is RHHW. Let's go back over to. So what happens is this is kind of a waterfall effect. As you select this, it selects options down here. So when you go at the beginning here, this kind of waterfall goes through the whole form. So when you go back here to single and change to multi or something like that, you're going to have to reselect all these values. Then what we've done is we've said, okay, if you have another cable of this type, we'll save those values so that you can use those same values the next time around. That's helpful when you're putting in a lot of motors and you don't want to, they're all the same cable types and things like that. So, but in a lot of cases, you'll have to just pretty much start from scratch. We don't want to use RHHW. We're going to use DHHN, and there you go. So we're going to go 10, and it selects those for you. Now you can see over here, here's your part numbers. Here's for your phase cable. There's your HW000 is their bare stranded, and you select your, we're calculating the size of the ground conductor. You look up here, you got this phase connection going to the MCC. If there was an N there, then we would have a value here. You can also, if you have a neutral for a service, you will have the option to not have a ground, because there's certain conditions where you don't want to run a ground and a neutral, and you would have the ability to do that as well. Right now, we have the fields available for voltage drop. I'm actually doing this demo with pre-beta software. So we're going to run into some errors and stuff, and some of the things we haven't quite completed. Voltage drop is one of them. But now you've also got conduit sizing if you want to run this underground duct. So you could select PVC. If you wanted to go schedule 80, it would require at least 3.5 inch. You could select 4 or whatever. So there's how you do cables. All right, so we're going to save that cable. Now let me show you what happens. So now you have, if you go up to power, click on power, you basically get all the devices in your power model. And this is kind of what you get in your summary page. There are almost 300 fields in the data table for power. So you can look at any number of columns in any format you like. I have created some fields, some reports for you, and I basically configured them so that this is a 15-inch monitor. My other monitor is 17-inch, so I can visualize more columns on the same space. But to not have to scroll, if you got columns over here, you got to scroll them right and left so you can see more columns. But I've set up the reports so that they'll fit on a 15-inch screen in most cases. So you want to look at, this is basically what we would call your general. So you get your ID tag right here. You get your from. These are device, there's your device label, your VLL, your phase wire connections, phase connection, ABC, your size if you have it. And you have the ability to look at, as this grows, this will get longer and longer. So I have added this ability to say, okay, maybe we got 100 different devices and we only want to look at, say, MCCs. Okay, so you unselect all and say, let's just look at MCCs. So basically what it will do is sift through this entire model and it show you the MCCs. And if you wanted to look at things like, okay, what kind of connected KVA do we have? There's your different KVA fields. If you wanted to look at any number of different ways to look at the data, connected amps, depending on what you want to look at. So you can look at that. And we're going to select all. So it can get kind of confusing, but you will get used to reading it. And as you move to different points in the tree view, it just displays those sub branches. So it's a really nice way, but it can get complicated, as you will see. So what we're going to do now is we have a MCC2 tied to our our new service. We've got an existing lighting panel. So let's, this is a service entrance. So now let's add, you know what, we're going to do a sub panel from our existing lighting panel. And so we're going to take a circuit breaker and we're going to drop it into our existing. So this is what you get when you drop into a parallel device, which is what a source is without not being service entrance marked. So this is a non-service entrance. So we're going to call this LP1A. So we're doing a sub feed, and let's make it, say 100 amps, and it's 240, 120. So it's a 2-pole main. So this is expansion 240/120 volt lighting. Now, I'm going to show you a little bit of, okay, so you see a part of up here. Now, you'll see that on a lot of situations. And what happens is that, so we have a source over here that is actually, it represents an existing lighting panel. So you can call this, excuse me, this is a circuit breaker. This is not a sub feed panel. We're adding a circuit breaker. So we're going to call this, maybe we got to go to circuit breaker 13 position to put a 2-pole from a space standpoint. We need to drop a 100 amp 2-pole into circuit breaker position 13 of LP1. Now, what happens is that CB13 can be used ID tags are unique. If you have an M12, you can't have an M12 anywhere else in the project. So if you created a motor named M12, that is unique. However, some devices, they are contained and within other devices. So like circuit breakers, you add circuit breakers to distribution panels. You add starters to MCCs. And what happens is that you can label those with numbers that are used elsewhere. But what we do is we take that number, say CB13, and we append it to the end of what this part of tag is. And in this case, it's the source, which represents a distribution panel. So let's just say, so let's put that in. So now we have CB13 that's part of our project, which is added to an existing panel. Now let's look at, see here, we've got under connected amps. Now you see this actually has full tag column in it. So if you look at that, now the full tag of this CB13, so really, if there is no part of, then the ID tag itself is unique. If there is a part of, you can reuse that tag, but it has to be used as part of another panel. So this is CB13, part of LP1 existing, which makes a full tag, and this is the tag that's unique. So let's go ahead, and now we're going to add another distribution panel downstream of this. And in this case, let's going to call this 1A. This is sub feed panel. All right, LP 1A. All right, and in this case, since we're coming from a breaker, in this case, our main device option is we have a main lug only. Now, distribution panels only have circuit breakers as devices that you can insert them. If you want to do fuse disconnect switches, you either have to use a switchboard, switch gear, or they can go into MCCs as well. So basically you've got, in this case, we're going to do main lug, and we're just going to put it right next to it physically. So we don't need a main breaker in here. If we wanted one, we could just put one in, and it says, well, you're being fed from 100. So there's your 100 amp main breaker if you want, but we're going to stay with main lug. Now we're back to our no cable routine here, where, okay, so let's run a cable from LP, it's actually from LP1 existing CB13, which is the source with the CB13. We're going to run that to LP1A. So we're going to do, in this case, this voltage level is 240, which makes it an L cable, okay? And basically we have ABN, so we basically, let's go ahead and select, and we're going to do THHN, same deal. And it has selected for this size. In this case, we're going to do a lot of, well, we're counting neutrals, which really doesn't affect us because even with the counted neutral, it's still only 3. So we're good. So there's your phase, there's your neutral, and there's your ground. If you were in a service entrance condition, you could say, okay, we just want to do the phase and neutral. But in this condition, we don't have a service condition. We're going to run them together. If you want to put them in RMC, it would take 1 1/4. And there's your different HWC part numbers, and that's how we calculate fill, all right? And you could do a length if you wanted to. So let's just say 15 feet. You can always come back and do this. And, you could change your ground specs if you wanted, your neutral specs. And here's the, actually we created a 42 circuit panel, okay, which you can see right here. But let's double click on the device to edit it. And let's say, just for visual effect, we're going to make it smaller, okay? So now here's our lighting panel here. These are all spaces, okay? And when you create a distribution panel, distribution panels are your typical panel boards. You will always get a left and a right. If you want to use, let's look at what we've got, what options we have. If you got switchgear, you have a switchgear option, SWG, they are always 3-phase. If you have a 240, 1.3 or 1.2 that you want to run from, or a 480, if you want to use any sort of single phase power distribution, you got to use a switch board. So basically these are always 3-phase. These are switch boards. They not only, they are also kind of the freeform switch boards that can do single phase, 3-phase, and they can take circuit breakers and fuse disconnect switches. They can also take voltage pressure switches if they're large enough. Motor control centers have to be 3-phase. You don't have any other option. MCP is really a breaker in a box, and it's a more detailed option. It's in here for individual panel design, and we'll go over that in a future video. Here's your different motor control devices. Once you have a motor, I'll show you how to use these in just a minute. You got an ASD, a full voltage starter, and a reduced voltage starter. But you also have distribution panels down here. These are your standard. They can be large, but they will come in a left-right arrangement. Your whole options on protective devices are circuit breakers. You can install your distribution panels, come populated with spares for each space, but you can install spaces in MCCs and switchgear and just define them. All of these tags are basically to simply categorize equipment devices for reporting purposes. You've also got a fuse disconnect switch, a voltage pressure switch, and then a fuse only. And these are for things like protecting power distribution blocks and stuff. You'll use those quite a bit more in an MCP than just out in the field. All your different loads that you have are motors, heaters, light fixtures, receptacles, a control panel, which is just a defined load. It can be either single phase or 3-phase. And what's called an area load. These are code-based loads that connect directly to distribution panels or switchboards only. And they are there so that you can know what your derated loads are based on the code rules for square footage, based on usage and occupancies and occupancy categories and things like that. So you can kind of play around with that. You do not run a cable to an area load. They just connect directly to, well, let's put one on here and I'll show you how it works. They connect directly to distribution panels or or switchboards. And so here if you wanted to do that, but they have no cable, so you have no cable option. So let's just say ALD, and we're going to do some office non-dwelling. We're going to add some manufacturing facility square footage, and we're adding, let's just say 50,000 square. Let's go, yeah, 50,000, and it's just one. So we got 50,000, and basically the unit load is 110 kVA. And you can see all of a sudden you've got a warning, because that tells you that, voila, 100 amps is not big enough. And this is what a warning looks like. So basically, we should have a connected load here. We got some things we got to work out, but that's what a warning looks like. So that's your area load right there. And since this is even a pre-beta version of the software, I can write that down. So we got ALD. All right, so let's just delete that. Okay, this is your right click, you select it, and then right click and delete device. And there you go, and the warning goes away. So to add a circuit breaker down here, let's just go to power, protective device, circuit breakers. And we're just gonna we're just gonna call this CB1. We don't know what, and let's give it a 20 amp. Okay, so this is a good time. So circuit breaker, we want this to be, let's just say we want this to be a ground fault trip. But you see, you don't really have an option for ground fault. So let's go to attributes, and let's go to circuit breaker. Okay, these are the different attributes that are available in UserData for circuit breakers, and we don't have ground fault. So we want to add a GFCI type breaker, and we don't have it. All right, so we're just going to cancel out of this. Let's just press OK. So we have now converted this spare to a circuit breaker. Okay, so let's go. We're going to launch UserData, and we want to add a circuit breaker option. Okay, this is UserData. Now, if you are in a project and you do file launch UserData, it will launch the UserData file that you have referenced in your project. So that's the one we're dealing with here. If you have multiple UserDatas and you want to open those instead, you need to close your project. And then if there's no project open and you say launch UserData, then it allows you to select whichever UserData file you want to affect. So here's your ASDs. These are your drive information. You can see all the different, you can see the different columns that go in here. You can edit it. Here's where you would select your attributes for particular drive. And you put in this case, you would put in a manufacturer, a style, a duty, your input, all your different ratings. Here's where you rated input, and here's where your rated output is. And then when you apply an ASD, it then goes to find the drives that you selected and selects the smallest one that is big enough for your application. So that you got ASDs, you got motors. These are to calculate your voltage drop current. For motors, your actual full load amp values are, pardon me. Okay, let's continue. Had to mess with the dog here. Okay, so these will, when you do a motor installation, if there is a value that matches a code-based table from a voltage and a size standpoint, it will use the code value of full load amps. However, to do voltage drop calculations, you need to actually know what the true running current is going to be. So you would put size, power factor, efficiencies in this table for those values. Here's your cable table, and right now there's about 4,000 records in here. We'll look at this in detail some more, but if you wanted to you can poke around, just edit a load. Here's all the different things for all the different cable types. and you select them all. Let's see, where's your installation voltage? I don't think you, oh, that's right. Here's what you do. You select your usage over here. So is it an N cable, an M cable, P cable? If you want, when you're looking for a control cable, if you want it to show up, if you want a cable to show up when you do a control device input and you ask for a control cable, you need to select usage here. Here's your applications for Raceway. If you want it to be able to be used in a cable tray, when you select a cable tray, if you want this, the cable tray to come up as an option for that particular cable, you need to have selected cable tray here for application. If you want features, if you know, for any sort of special, maybe a area classification rating or something for those cables, you would select them here. So you can poke around in there. That's your cables. You've also got device ratings. What I do in the program is most of the components, except for drives and cables, are generic, and you just pick voltage, size. You pick, for example, for breakers, or say disconnect switches, you have just voltage and size. If you have, let's see what other devices we've got. If you've got fuses, you're going to get a frame size, you're going to get a class, and this would define the clip size. You've got a class, you've got a speed, you've got a size, all under device. So if you don't see what you're looking for overcurrent devices, bus, come and look in device and you can add them. All right, and I'll show you the add. Got system voltages. If you end up, needing some voltage that's not here, you can add them, and then it will populate. If you want it to show up under the source label, it's here. If you want to show up under as a secondary voltage on a transformer, you would select that. You got light fixtures. We'll get into you can poke around and look at those receptacles. Here's your different options on receptacles. And now we're going to look at device attributes over here. So we were looking for a breaker. So let's look for circuit breaker. Here's all the devices that we have available. So we're going to do circuit breaker, and we're going to select trip unit. All right. And you can see this is the list that came up. So what we're going to do is we're going to insert a row. So we're going to insert, basically attributes are what you see here. The attribute is actually the code. Oh, the attribute, actually, you've got a description for the attribute, but what is saved with the actual device in the power or the cable table are these codes. And you create these codes. Codes consists of a device and a group. So these are all B's, and we're just going to add another one. So it doesn't know what the code is because it's going to pick the next available. So we want to put in GFCI. Okay, and that is going to be our. So now you see code B09 is GFCI. So we're going to now I've got this save and exit. Okay. It's going to write the user data back in, and let's click on what you got to do is you got to go out of power and then back into power. So let's go back to circuit breaker, and that's what it is. Let's double click on it and now go over to attributes and look at it and say select and trip unit, and voila, there's our GFCI. So now, and you kind of want to do this, especially for breakers or things like, starters or motors, because all these attributes are kind of a hassle to put in. If you've got like a motor starter and an MCC, and you've selected control power transformer and, communication options and things like that, you don't want to do that every time. So I'm going to show you what you can do here is, so we've selected this and we're good. And we basically want to populate the left side of this with these GFCI breakers. So we're going to say copy and then select them all, paste device. And what it will do is now it's filling in space 3. You just say, okay, space 4, 5. Okay, so now you have the left side now has breakers in all their side. Okay, so let's just look at, go back up to general. And there's all your breakers. The first one's tied to A and neutral, B neutral, A neutral, B true. Neutral, they're all 20 amps. And let's just click on one. Look at, well, we did, that's one. Let's look at, let's down here. Let me look at attributes, and that's got a GFCI breaker as well because we copied it. We did not create it direct. So now let's go to load and receptacle, and we're going to say, and here's your form. And what you'll end up doing is go ahead and just drag things into the power tree view. If it doesn't go there, it'll give you a warning. So we're going to just say, okay, so either this is 0, 1 to 10. So we're going to put in 10. These are non-dwelling, and what did we say? Manufacturing facility. And let's just do 10 of them. Okay, and then press save. So now you've applied load to this, and there's and since it's a 20 amp breaker, the circuit, and in this case, let's just do, you can run single conductor multi, play around with it. You look around for what cables, there's multi-conductor. I think we have some multi-conductor, 3-conductor, and in these cases these are tray cables. So there you go, and it sizes the single conductor. It's kind of interesting because since this is a single conductor, your fill limit goes up to 53%, but we're going to keep it at 40. So it tells you what size circuit breaker. There's your one cable, which is, it's with ground. If it had the neutrals included in the cable, the ground's included in the cable. So there's your cables. And that is an L cable. Here's all of your different cable types. This is your voltage and how we define the different cables. So now we've been creating cables all along. We've done a couple of L cables and a bunch of P cables. If you were to do a high voltage system, you would be creating N cables and M cables. The next video, we'll talk about inserting control devices, and that would then create your control cables, your signal cables, your communication cables. So there you go on that. So you're creating cables. So there's your power. So and you can create, we have light fixtures, receptacles. Let's power loads. Let's put a light fixture on the end of this string. And now see, you've only got available 600 VA. So you basically non-dwelling manufacturing light fixture, commercial, what do we got? Indoor, and let's do wraps. Sure, whatever. I'm not a lighting guy, so you guys are gonna have to pick all this stuff out. 3000 lumens, let's do kind of white. There you go. So this basically, and we're gonna do, I don't know, 40 watts, and we're gonna do, so we got about enough for 10 of these. It'll tell you really what you've got is you've only got enough for, actually it's 13. So there's your 10. Oh, great, I got some sort of error here. All right, well, that gives you, we got to still work on that. So, but that gives you an idea how that works. Okay, so let's go back up to, so we showed you how to use a distribution panel, put some devices in there. Let's put some motors in now. This is the one case. Most cases throughout, you have to build your system with your protective devices, your fuses, your breakers installed. As I was saying, when you build your power model, and let's go up here and just click on this top and let's explain on branches there. Oh, I guess we don't really have anything to expand all branches. So you can see your, okay. So in most cases, we require you to put in overcurrent devices when you insert your devices. This is one case where you can connect motors to MCCs, and we do that you have this utility here. I know we do lists of motors, and you have this ability to, I'll show you how to do this later on, or not in this video, in another video, but you have this ability to take a spreadsheet where you have your motors, and rather than having to drag each one of them in there to the MCC, we allow you to import them. Well, in order to do that, you need to be able to drag them to a single device. So what we do is, let's just go ahead and take a motor. Heaters is very similar. We're probably not going to have time for heaters. So let's just call this M1. And let's just make it 100 horse. And you'll see that it says table. This is the source field, which is where did you calculate this value? Make it W. It's calculated based on that power and efficiency that's in the user data that we saw. Since this voltage value that's matches in the code base table, it gives us our FLA. So what we do is we just basically say, okay, we're gonna insert this motor into that MCC. So, but you don't have to have a starter. And if we want to do, in this case, let's do multi, because down the road we're going to talk about cable trays, and we're going to want to do a cable tray. So there you go. We're using THHN, THWN. It's one, turns out to be, there's 125% is your circuit size. It's ABC. 125% at 124 is 155. And we'll be running into a one process area. So we're going to derate by 104. And then basically we have an uncorrected size, which uses 75C table as the base for uncorrected size. We adjust and correct. Then 16 is actually the 90. Don't we have a? Yep, 90 column. And then here, and we take the larger of these two values. That's how we size our cables. All right, so you've seen all this stuff before. So now you've got a cable going to the motor. Now, what you do is now you say, okay, well, I want to put let's just say a drive. We're going to put a drive on that. So you just drop a drive on there, and it basically says for the manufacturer, that's too large. So it's selecting another manufacturer and style. The style we had previously looked at was not large enough, so it had to go down to the PowerFlex 753s. It picked 100 horse with an output rating of 125, which is just large enough for a 100 horsepower motor. Now, when we do our motor calculations, our circuit minimum size for this particular motor, rather than using this value down here, we use this input rating value. All right, so there you go. So let's create, here's an option, and sometimes some of these devices can be copied like we tried with our circuit breaker. So let's try it again. And so let's just copy paste this device, M2, and let's make that 200. Okay, and you're going to have an M2, and there's your $300, what is it, 240, and then 125% is 300. So there's your 1350 we've selected. You notice you don't have to reselect these things again because we already selected them last time. So if you're doing a bunch of motors, for motors, you actually have the ability to multi-paste, and that would be, so let's just do 2 more of those. So let's do M3. Now let's just say, okay, we're going to do M1 again. Voila, ID tags already exist in the table. You need to create a unique ID tag. So let's make this M3. Process motor 3, and we'll make that 75. Okay. And then your cable for that. Okay. Then M4. Let's make that a 50. And there's your cable for that. So now you've created some motors. One of them has a drive. Let's go ahead and take that drive. Let's copy that drive and see if it works. Drop it on the motor. Paste device. Yep, it did. And it automatically created a tag, the correct tag. It puts ASD hyphen whatever the motor tag there, and it copied your process motor up here to your ASD description. So down the road, if you need to print out labels and things like that, you'll be able to generate those reports. And you notice it's selected at 200. So there you go. Okay, so you got two motors with drives, and let's go ahead and use, now we want to try a motor control. We're going to do a reduced voltage. Let's put that on M4, and it's going to be a solid state starter. It turns out to be a 50 horsepower, which is the FLA that's coming up from the downstream device. Same deal, created the tag. Now, again, look at this. It's a part of when you drop a starter or an ASD on a motor that's connected to an MCC, it assumes you want to make that MCC as part of the MCC, that starter as part of the MCC. If you were to put a circuit breaker here and drop the starter, I believe either on the circuit breaker or on the motor, it will put it in between, and it will basically not be part of the circuit breaker. So you just got to play around with that to see how it works. You also have attributes for drives. You know, you can select all sorts of things, keypads, pilot devices on the front of starters, and oh, this is attributes for reduced voltage starters. So you kind of get the idea of how all this stuff works. So that's that. And you can see there, and you're looking up here, and now our circuit minimum size, let's double click. Basically, here's our summary page. MCC2 has a circuit minimum size now of 569.4. The actual connected amps is only 525, which makes sense because you got 25% of your largest input drive or full voltage motor, whichever is larger, to goes into your circuit minimum size that is not in your connected amp. So it's slightly larger, but hey, we got 4,000. So let's put a starter. We'll just do a starter just to show you how do you do that. Wait a minute. Motor control, full voltage. This is just a full voltage, same thing. And it gives you the whole thing. So it selects it all for you. You can create. Now, also, it does not, here's something I don't know if I've showed you before, but on these devices that are part of something else, that is a manufactured joint. That's the bucket in the MCC, or the breaker that's bolted or plugged into the distribution panel or switchgear or whatever. And you don't need a cable in that situation. You don't need to have a cable to go from MCC2 to the ASD that's mounted in MCC2. So whenever you have a part of, it automatically checks the no cable checkbox. You can uncheck it and create a cable if for some reason you needed to, but in most cases, this is going to be the way it's going to work. So you will not, when you tie ASDs into MCCs, you will not be creating cables because you don't need a cable between those two connection points. So, all right, well, that gets us to probably the end of it now. That's pretty good on power. I've done motors and distribution panels, lightings, receptacles. Try the higher voltages. Play around with service entrance and just non-service entrance sources. I will do another video. We're going to talk about cable trays in the future. We're going to talk about control devices. We're going to talk about raceways. And we're going to talk about reports. So in the future, but this ought to get you going. It's actually the same. If you want to get a jump start, it's the same idea for controls, except you drag them to controls. Now on controls, the idea is if you drag a control there, for the first control that goes there, there needs to be, since you're dragging your first control and you need a from, you don't have a source for controls. So you need to create one MCC or one control panel in Power to start to basically act as the source device for your control system. So you go ahead and I just create a 120 volt PLC panel. I drag a CP there, and then you have something to start your controls as the original from. Then once you've got controls in there, you can use your control devices as from devices. So give that a try to get started, but I will be doing a video on that shortly. I appreciate your time. Sorry it took so long, but as you can see, there is a lot to this. So I will see you again shortly in the next video. Take care.